16th. Take you from there. December. So they say your results going to come this month. Scroll, scroll. So online students, just give me a quick check. Can you hear me? And how about the whiteboard? I'll send you good vector. Okay. Sure. Yeah. Okay. So where's your friend? Ferguson. Your friend. Yeah. Can take a tube from there. Just give him. Right. So today we are going to move on to a little bit tough physics. Okay. So from today it's going to be vectors. Uh, so before vectors, before approaching to vectors, we have to have a good knowledge on mathematics, basic mathematics. I mean advanced level basic mathematics. So here basically, if you come to mathematics, okay, uh, okay. So now I have given you the first tute. Okay. So first 2 hours until interval, and let's take part from the next session also. We are going to cover the basic mathematics parts, and we are going to move on to real vectors and have a good knowledge on vectors. Okay. After that, we will move into micrometer screw gauge, the second instrument. It's really easy because we have the knowledge of vernier calipers, vernier readings, and you will know how to take reading, how to calculate least count from the screw principle. So micrometer screw gauge is much easier to have a brief knowledge. Okay, now let's move on to uh, mathematics in physics, basic mathematics in sense. It's going to be how many pages do you have? Mathematics. You have only 2 pages, 4 sides. So it's going to be trigonometry. So we are going to vectors. You have to have a good knowledge on trigonometries. Okay, trig. All right, that's trig. Right. So can you remember Staccato? What's it? Staccato. Right. Cos is equals to opposite over adjacent. Right. So basically, is the really most important fundamental. Remember sine Staccato. Staccato. Okay. So Staccato. This is, I mean, after you do questions, this is going to be really easy. You are going to get practice to this. So to give you a small brief idea, this is sine, okay? Sine, let's take the angle is theta. Sine theta is going to be opposite side over but hypotenuse. Hypotenuse. I'm going to write it short form, right? So if we move into cosine, call it as, we write it as cos theta is going to be adjacent over adjacent side over hypotenuse. So before coming to these, we have to draw a triangle, right? Trigonometry. That's why we call it as trig. Tree. So we have to draw a shape with how many sides? 3 sides. Online students, if there's any problem, just let me know. Can you hear me about this? Right. Okay. So let's draw a small triangle here. I'm going to draw a small triangle shape. What's special in this triangle? Other than other triangles, this is going to be what? 90 degrees. This is a right angle triangle, 90 degrees, right? So if we take this angle as theta, you can call it theta or theta, whatever. Okay, this is theta. This is going to be the opposite side. This is going to be the adjacent side, and this is the hypotenuse. Hypotenuse. Okay, so this is cos theta, sin theta, and it's coming to tan theta. Tan theta equals to what? Opposite, but not like this. If I write hypotenuse here, it's going to be like sin theta. So I'm going to write here adjacent. Okay, three are different to each other. They are unique. Okay, so now what we are going to do is we are going to write the things box. Okay, you have a small box here. What you have to do is the triangle is flipped the other way around. So I'll name it here. Right. This is going to be A. This is, and this is here, right? Now this substitute the side of this triangle here. Okay, opposite in the sense it's going to be AB, adjacent BC, and hypotenuse AC. Soon, fill it there as a box. Fine. So now we are going to go into some basic angles in physics. Okay, so there are a hell a lot of angles. We take up to 0 to 360. There's a lot of angles. So basically, we talk about 30s, 60s, and 90s. 90 degrees, 60 degrees, and 30. All right. So basically, we are going to look into multiples of the angles. 30, 30 is multiple, 60, 60 degrees multiple, and 90, 90 degrees multiple. Okay. So you have a table here. This is how you fill. So you are not going to fill this from top to bottom. This is how you think. So normally physics ALL people, I mean, we came from, I mean, basically single medium students are, there are a lot of single medium students. So basically they remember this from here. Because I went to a single medium, X class. So I'll tell this short trick. This is going to be really easy. So you remember this as cos 60. So we call this in single as cos hatter. Okay. And is going to be half. Okay. This is how you move into this picture, biology people. Okay. So we call this as cos hatter bhagya. So this hatter we are going to read as hatter. Okay. So this we remember this as cos hatter bhagya. Okay. From here only we are going to start this table. Okay. You are English medium students, but this is easier. As Sri Lankans, we should have something unique other than them. Right. So we are going to start this from here. So you have cos theta and move on to the 60 table, 60th table, and write it as half. Okay, write it as half. Okay. So I'll write it here: sin theta, cos theta, and tan theta. Okay. You have only three numbers. So okay. So you have only three fractions that you have to remember. One is half, The next one is 1 over root 2, 1 over root 2 and root 3 over 2, root 3 over 2. Okay, so these numbers have 2 in their denominator. Let it be root 2 or 2. There's a multiple of 2 there. Okay, a power of 2. So here these 3 digits are going to be changing in this part of the columns and rows. Okay, so this is how you write them. So let me select. I'll keep for our reference angles 0, 30, 45, that's 45, 180. So here 45 is there because it's half of 90. We need 45 also. So basically these 3 digits. I'm sorry, I took 90. So you can, instead of 90, you can take 45 as the main base. Please. So these are degrees. Okay. Now, first of all, we wrote cos 60 half. Okay. I said you 3 digits. So the next digit that's going to be in cos and sine is these 2 digits. This half and root 3 over 2 and half both have the same denominators. Okay, so you examine cos and sine, they both have hypotenuse, the same hypotenuse as their denominators. So we are not taking this now, we are going to take these two for sine theta and cos theta. Fine. So we marked cos 60 as half. Now the sine 60 is going to be the next digit. What's the next digit? Digit in the next fraction, root 3 over 2. So sine 60 is going to be root 3 over 2. I'll write it in this old format. Okay, I'm not going to write it like this. Save space, I'm going to write it like this. Dash. Right. So if you come to 60, okay, I'll draw a triangle. Explain this. Small a triangle. Okay, 90 degrees, a right angle triangle. If this is 30 degrees, how much is this? Every time it's going to be 90 minus 30. Okay, it's going to be 90 minus 30, and this is equal to 60 degrees. Okay, so let's take here opposite, adjacent, and hypotenuse. Okay, sine 30 going to be opposite over hypotenuse. Okay, opposite over hypotenuse. Okay, right. Now what I'm going to do is I'm going to find this sine 60, the next angle here. Okay, so this is going to be, look from here, this is going to be adjacent over hypotenuse because our point of view is here, right? That's going to be adjacent over hypotenuse. So people, from the point of view of 30, this adjacent over hypotenuse is what? What's it? It's cos theta. Adjacent over hypotenuse in the sense that's cos theta. But from a different point of view, next angle is going to be sine 60. So this is how you move from sine 30 to sine 60. Why? What's the relationship between 30 and 60? If you add those two angles, that's going to be 90 degrees. So whenever you make an angle, when you add two angles and if that come up to 90 degrees, it's going to be the cos of the sine. Sine of the cos or cos of the sine. Understand? Right. So let's move on to, now we are going to move to which angles? 60. The next is going to be how to make 90. I want to go to 30, right? So we are going to move to 30. So sine cos 60 is half. So here, if we take cos 30, that was the cos of 60. Understand? What? The sine of 30 going to be cos of 60. What's this? Half. Sin 30 is going to be half, right? Sin 30 is half. I'm going to write it. Sin 30 is half. So what is cos 30, people? It's going to be the opposite of this. I mean, the sin 60 is going to be equal to cos 30. Understand the basic principle? So cos 30 is going to be root 3 over 2. Right. People, start to fill this. Ready to start to fill this. Okay. So I said these are the main three fractions that you have to remember. Main three fractions. Okay. Now I have your question. So these three are one sine of something, cos of something, and the next one is what? Remaining trigonometric ratio, tan. So here root 3 over 2 half, and the next one is going to be 1 over root 2. So tan 60 is going to be 1 over root 3. 1 over root 2. What is? Here you have 1 over root. Have to have another. So the next couple of digits ratios that you have to remember is 1 over root 3 and the reciprocal of this 3. All right. So this is the next part. So from here you can take that. Right. So here, first page. Okay. I'll come to here. So tell me, you are going to make tan theta. Okay. Tan theta. Tan theta. But you don't have the opposite and the length of opposite and adjacent lengths and hypotenuse length. But you have only the value of sine theta, value of cos theta. I'm going to do this part. What I'm going to do is I'm going to write this opposite from here. But I'm going to subject opposite from here and write that part here. So if I subject opposite here, it's going to be sine theta into hypotenuse. Understand? So I'm going to write that. Sine theta into hypotenuse, height. What's this? This is the opposite side. So instead of adjacent side, I'm going to write this. I'm going to substitute this adjacent to here. So if I subject adjacent here, cos theta into hypotenuse is going to be adjacent side. So I'm going to write cos theta multiplied by hypotenuse. So hypotenuse is length and hypotenuse is length. Sine theta is a number, a ratio, decimal number. Also a decimal number. So here these two lengths are going to get cancelled off. So you can make a tan theta by dividing sine theta and cos theta. Right? So sine theta and cos theta is going to be opposite over hypotenuse. It is going to be adjacent over hypotenuse. The hypotenuse cancel off because they have the same denominator. So here you can remember this tan theta by dividing the cos sine by cos. Right? All right. So here if you divide sine by cos, this 2 to this 2 cancels off. That's going to be root 3. Right? So this is how you come to this root 3. Tan 60. Okay. So here you come to tan 30, you don't have from here you can't take a relationship. Okay, you can't take a relationship. But here from this you can take a relationship. So for this we took it from here. Okay, this we took it from here. But for here we can't take from anywhere else. Instead of that, we know a method. We are going to make tan theta dividing sine theta by cos theta. So I divide this by this. The 2's are going to cancel off. But now the root 3 is not in the numerator. It's going to be in the denominator. Okay. I'll give you some methods to remember how to divide fractions by fraction. This is going to be 1 over root 3. Okay. So finally, I'll give the bunch of numbers that you have to remember. This is okay. So we filled 30 and this. Okay, so 45 degrees is going to be the next number, right? So it's a little bit here. This 45 is going to be, we took, yeah, it's not like this. It's going to be light blue. One of the three. One of this is going to be 30. One of this is, and one of this is going to be 45. So first of all, before I start, I said three basic angles are 30, 30, C and 90. Sorry for that. It's going to be 45. Okay, because here you can make 90 from 45. Understand? Multiple of you multiply 45 by 2. That's going to be 90. All right. So now the next fraction is we used. If I take sine theta, we used half. We used root 3. Now the only remaining part is 1 over root 2. So I'm going to fill this in this direction. Okay, in this direction. I'll keep here. I'll write this. So this is going to be 1 over root 2. Okay. I'll ask you a question. So if people here, what happened? This 30, this 60 as a relationship. Okay. So this is going to be cos 30 adjacent over hypotenuse. It's better if I write it like, I'm going to equalize this part to cos 30. All right. I wrote sine 60 is going to be adjacent of hypotenuse. So adjacent of hypotenuse is cos 30. Now what I'm going to do is I'm going to erase this part, not this part. I'm going to take a relationship like this. Right? Cos 60 is going to sine 60 is going to be cos 30. Okay. Now I said you, if you add two angles and if that's going to be add up to 90 degrees, you are going to get the cos of the sine, right? So if you take here 45 degrees, I'll take here 45 degrees. So what's the next angle? 90 minus 45? That's the same 45 angle. So likewise, if I write these two steps, I'll write sine 45. Sine 45, let's take sine 45 is going to be opposite over adjacent, and I'm going to write the sine 60, the next part, next angle. That's also again going to be sine 45. And now I'm going to write this over adjacent over hypotenuse. I should write like this. So can you see something here? What's it? Sine 45, that's also hypotenuse, and the next adjacent over hypotenuse, that's also going to be sine 45. So you should see here, recognize that the angle is 45, the opposite over hypotenuse ratio is equal to adjacent over hypotenuse. Because these two are same angles, these two sides are equal to each other, isosceles triangle. Understand? So if this is sine 45 and this is sine 45, again this is going to be equal to cos 45. So again, sine is equals to sine 45 and that's going to be adjacent over hypotenuse, that is equal to cos 45. From here I can tell that this part is equal to this, isn't it? Can tell it, right? So if sine 45 is 1 over root 2, what is cos 45? Same as the sine. I say why? What's the reason? Because if you add 45 and 45, that's going to be 9. Understand? Okay. So I'm going to write here 1 over root 2. Okay. So how I'm going to tan? What's the method? Divide this by this. Okay. Online students, can you hear me? Online students? Yeah. Okay. Right. Where are we? We were here. So if I divide these two fractions, it's going to be 1. Okay. So now here I'm going to go to zeros and 90s. So every time zeros and 90s in sine and cos theta is going to be either 1 or 0. Okay, either 1 or 0. Right. So if you go to, if you look this order, this is going to be half 0.5. Okay, I'll write it here, 0.5, and from here to here, this is root of 2. Root of 2 in the sense the 2 is 2. You take the root of 2, that's going to be lower than the value of 2. So the denominator is going to increase. So the final value is going to increase. Denominator is going to decrease. So the final value is going to get increased. So the 45 degrees ratio is going to be a little bit higher than this. Okay. Now if you compare these two, the same denominator, but the numerator has increased. Okay. So this third angle is greater than this. Okay. Now I'm going to compare these two. Okay. What happened here is the numerator has increased and the denominator has increased. But if you take overall, from overall, root 3, and if you since the denominator has increased, the overall value will be decreased because that's inversely proportional. Okay. But more than the decreasement due to the denominator, the root 3 increased the value. If this is decreased by, let's take, this is going to be decreased by x. So this is going to be increased by y, and y is greater than x. So every time this is going to be greater than that. But this root 3 is greater than 45 degrees. So if you see this pattern, this is gradually increasing. Gradually increasing. Now I have to put 0, I have to put 1 or 0 here, or 1 or 0 here. So if this is increasing, this should start from an origin. Okay. So here, if this is 1 or 0, I'm going to take 0, and from here I'm going to take 1. Okay. Right. So that's how we fill this part. This is going to be 0, and this is going to be 1. Right. 0 and 1. So in cos theta, it's going to be the inverse of that. Inverse of that. Right. But in tan theta, it's a little bit special case. Here, this is going to, if you see this pattern, this is increasing, gradually increasing. So root 3 is going to be 1.732. So this starts from 0, and gradually this reaches the value of infinity. This reaches infinity. You are writing infinity like this. Okay. So the only remaining angle now is 90, 180. So this is going to be a little bit different, 180. So let's go into 180 degrees after we complete a graph, one cycle. So 180 is going to be half a cycle. So while we are going to complete a full cycle, let's see what these values are going to come. Okay, right. So soon copy this down. Well copied. Let's move on to page number 2. All right. So this is a part that you have to remember. Okay, I mean there are now short methods, in the sense you don't want short methods to remember this, because gradually you will remember this, because in every lesson you are going to come into sine, tan and cos, but these values for now you are going to forget it. So this is the easiest method to remember. Come to cos 60, that's half cos theta by i. From that you are going to move on to the next cos theta, and from that you are going to move to this, and from here you are going to move to this, then tan thetas, complete in tan thetas, and the next remaining digit is 1 over root 2. You are going to write the same thing and divide this, and you are going to come to tan 45. And after that you have to know this is increasing, so sin theta is going to be 0 and 90 is going to be 1. Here cos theta is 1 and this is going to be 0. Right. So tan theta, you have to remember, this is a special case. It's going to be like sin theta, but here it's going to be the opposite of that. Okay. Okay. So now we are going to draw curves for, I'll draw some for sine theta. I'm going to draw sine theta, cos and tan. I'm going to draw this for a quarter of a circle. Quarter of a circle in this how many degrees? 90 degrees. So I'm going to draw this graph until 90 degrees, not more than that. So from that we can complete a graph. Right. Okay. So this is sine theta, cos theta, tan theta. All right. So the x-axis is going to be theta. I haven't mentioned that. Just we have mentioned this is theta. No, right? So mention it. So the x-axis is going to be theta. We are going to see how the trigonometric ratios vary with the angle. This is going to be sine theta. This is going to be cos theta, and this is going to be tan theta. All right. Okay. So every time you have to remember this. We are going from 0 to 90 degrees only. 90 degrees only for this, only for now. Okay. So this is going to be every time an increasing curve. It's going to be a part of a circle. Every time this is going to be the graph. Okay. And every time cos theta. Okay. What's the value of cos 90 degrees? Just turn over the page and tell me. 0. What's the cos 0 is equal to? 1. So the opposite of sine is going to be in cos. Why? You examine this table, you examine this, opposite of this is going to be in here, cos and sine. Here cos 30, that's here, and the half is going to be here, and the final part is going to be in here. And if you take 0, that 0 is here, and this final one is here. So the opposite of this is in this side. If you take this and flip it over, that's going to be this, cos theta. So the graph is going to be cos 60, cos 90. If you go to those graph, this angle increases. So cos 0 is here, cos 90 is, let's take this as 1. Okay, I'm going to take here also. So this is going to be 1 again, right? So if you come to cos theta graph, so you don't want to know this stuff, but this is that much basic. This is going to be flipped over. Cos 0 is going to be 1 and 90 is going to be this. So it's going to be the opposite of this graph. So this should meet here. Okay. So if you divide into 3 parts, 30 and 90, those values are going to be here. Those values are going to be here. Cos 30 and cos 90. Here also that same part. Sin 30 and sin 90. What you have to do is you have to mention these values. All right. Now if you go to tan curve, here this is 90 and this is 0. If you go to this, tan T0 is 0 and tan 90 is, okay. So here if you know these values and if you draw a graph, this is 1, this is going to be, and here 45 degrees, tan 45, this is the exact half of this. So tan 45 was 1. Tan 45 was 1. So I'm going to mark that 1 here. Okay. When it comes to tan 45, that's going to be 1. Tan 45, that's going to be 1. This is going to be, here it should be, when it's coming to tan 45, it should be in 1, and when it's going to 90, it should be in infinity. In the sense, The infinity of this this axis, y-axis, is going to be up there, up in the sky. So you can't reach it. Whatever the time you spend, you can't reach it. So the infinity part, what you have your marking is like this. How you mark an infinity? You're going to draw this line at the top, okay, and this line, the exiting line, is not going to cut this axis, this 90 degrees. It can't cut like this. It can't cut. Why? You cut this 90 degrees, then that tells that cos 90 has, tan 90 has a value, but tan 90 never reaches that. Why? It reaches it in the infinity, when it's infinity. So it never reaches it. Okay, that's the terminology. So this is how you mark an infinity. How you mark an infinity. What you're going to do is you are going to draw a parallel line here, parallel line to this 90 degrees. Why? This is going to go to the infinity. All right. Now I'm going to join this point. So this is going to be like this. So since I have drawn this a little bit bigger, I'll do it from here. It's going to be like, I think I have to. Point, it is parallel. Okay. So this is if you shrink this graph, that's going to be like this. Okay. So before drawing that, don't yeah, here also you have to draw like this. It's going to be like this. If you shrink this graph, it's going to be like this. 90 tan theta, and this is theta, and this is 90. Usually when you're drawing this sin theta, cos theta, tan theta, you have to draw like this. And this graph, just keep in mind, roughly this is going to be like this, a graph like this. Okay. Right. Now we are going to complete each graph. Hmm. So we are going to complete each graph for a full cycle for 360. So this is what you have to remember. If you come to sine, I'll draw a small graph. Come to sine. Every time is 90, this is 180, 70, and this is 360. Okay. So here, can you see this tiny graph? You can see this graph? Yeah. After I write, I can fine. That's right. This 90, 90, 180. So I'm going to skip by 90 degrees and 90 degrees. Okay. 90, if you plus 90 to 90, 180. If you add 90 to 180, that's going to be 270. You have to remember this number. 270. If you add 90 to this is going to be 360. This is a whole 360. So from here to here, that's going to be 90. From here to here, that's going to be 180. 180. From here to here, 90. From here to here, 180. From here to here, that's going to be 270. And from here to here, this is going to be a whole circle. and that's going to be 360. This is what I have drawn here. Okay, this is the angle theta, and this is the, I'm going to draw the sine value. Okay, now if you move on to the table, just turn page number 1 and just tell me the values. What is sine 0? What is sine 0? Sine 0 is 0. So I'm going to mark in red. It is going to be here because this is the origin. It's going to be here in this point. Okay. What is sine 90? Let me draw a dotted line here. Parallel line. Okay. So 90 is going to be 1. So what I'm going to do is 9. Draw with me. Okay. So sine, I'll mark this as 1, and this is going to be 1, and this is going to be minus 1. Okay. So here, what? 1. Okay. So to complete this, is going to be a quarter of a circle. Okay. So every time when you go by 90 by 90, it's going to flip the mirror of this, and that mirror is going to be flipped again here and here likewise. Okay. So if I flip this side, the mirror image is going to be like this. Okay. So I'm going to flip this in this side. First I flipped here. I'm going to flip in this side. If I keep a mirror here, it's going to be like this, a part like this. So that's going to come in this part until 270. Now I'm going to flip this here. So normally a sine graph is going to be a sort of like this, sort of in the sense, this is because I drew by my hand, but it's actually a like this. Okay, it's going to be a curve, a beautiful curve like this. So this graph is symmetrical, not symmetrical. I mean, if you take part by part, if you take this part, that part is the opposite in the mirror image of this, and if you take only this part, the half of this part is going to be the mirror image of this. Understand? So sine curve is going to be like this. Every time you remember, sine curve or cos curve is going to be a curve. It's going to be like this, as S, a flipped S. All right. Copy this down. Restroom. Yeah. Aside, just draw a shape like this to remember it at once. Okay, soon. Now I'm going to draw the cost curve of this. Cost curve of this. Finish? Okay. Right. Now I'm going to draw the cost curve. So if you go to cos theta, cos 0 is what's the value? What's the value of cos 0? 1. So I'm going to use a magenta color. So this is going to be 1 here. And cos 90 is 0. Cos 90 was 0. Now can you see that? This is the opposite of sine. Hard to point. Okay. So this is going to be a curve like this. A curve like this. A curve like this. So now if you examine the sine angle, sine graph, examine the sine graph, can you see that this is the part here? The part here have been, I mean, sine theta starts from here. Sine theta starts from here and it finishes here when 90. But cos theta starts from here and finishes at 90 here. So this part of the sine curve have been placed in the cos curve in 90, between 0 and 90. Understand? So the next part is going to be the other part of this. Which part? The next part is going to be from here to here. Okay, so I'm going to draw that. That's going to be like this, curve like this. And next, this part, I'm going to draw that curve like this. And next, if I continue this, is going to be again a curve like this. So this part is from here. Okay, so sine is going to be 90 degrees in front of, sorry, cos is going to be 90 degrees in front of sine. Okay, so again, if you complete the final part, is going to be the first part of the sine curve like this. So this is sort of like this. Start from here, it goes like this and come to here. Just remember the values, the graph, that's enough for physics. You won't have a like this. Okay, online students, take a screenshot. Take a screenshot. Very good. Smartboard choice really mess. So people, this is 90 and 360 and those stuff. So don't mess up the things. Okay, here. All right. So now I'm going to move on to tan theta. Tan theta. Tan theta. Okay. So the first part of the graph was like this. It starts from 0 and it goes to infinity. Okay. Now it's going to be the mirror image of that. Like we drew to sine theta, it's not going to be like this. This is a little bit different. This is going to be from here to here. The second mirror, exact y-axis mirror image and then x-axis mirror image. And after that, it's going to be a curve like this. And then it's going to be again the next part from here. So this is going to continue. So this is like this, 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 this. So it's like this, like a pattern. So these lines never meet. Which lines? I'll mark it in magenta. These points, this point and this line never meet. This line and this and this and this never meets, since it is infinity. Okay, so not only to 360 we get sorry not only until 360 we can draw this furthermore until, if you had 90 degrees for 360, that's going to be what, 400, 450. So that's going to be 450, and again this part is going to be coming here, coming in the sense this is going to, we are copying this and pasting here, and this is going to be like this. Understand? And if you take another 90 degrees, that's going to be 540, 540. So if you are going to draw to 540, we drew this. Now we are going to draw this. It's going to be like this, like this. And from here, it's going to continue like this, like this, like this, likewise. Okay, so after that, you have a small diagram. Remember, I'll give you some questions to write. So was it raining yesterday? Look here in the diagram. Yeah. No. So the coming week, the next week after that, it's going to be holiday, right? 30th, 30th of May, Vesak. So don't cut classes. That I have to remind you all. This year there's plenty of holidays. We have to use them. So do you all know what's going on these final year batches? The ones who is going to sit for this A level. Normally, after the result comes to the batch before that. Now 2026 batch is going to write the A levels, right? So when the results of 2025 students, the previous batch, 2025 is released, there is almost 7 to 9 months, 7, 8 or 9 months to the next exam. Okay, normally until now. But it was due to the corona, those, but Easter, there was an Easter blast, and those, and recently because of those floods and stuff, adjacently to continuously to 4 to 5 years, this was happening 7 to 9 months. Before that, the months to prepare, I mean, if you are going to shy, okay, there's only this much month to get prepared. But this time, there's going to be only 4 to 5 months because they have dragged the A levels. So normally A level is on December. So normally it was on the next year's part. Okay. So in this time, it's going to be December, but they started after the results of the previous batch was released. So not like for 2025 batch, our batch 2024 batch, this time they have only 4 to 5 months so only 4 to 5 months remaining. So the class tuition sirs are in a real problem because they have planned for how many months are there? Only to subtract from, if let's take the average from here, 8. We take 8 from here. The average is 8. Here the average is take 5 from here. So there are only 3 months. So in 3 months, how many weeks are there? 3 times 4 is 12. So they have planned to cover the syllabus on those months. Only there's remaining 3 months. So a lot of classes are in a real trouble these, and mainly a lot of students. They have, like, compared to the previous batches, the students writing in 2026 haven't covered the syllabus yet. So the result is going to be a little bit lower compared to the previous batches. Understand? So if they can cover the syllabus within these months, remaining months, however, by watching recording or something, they are going to get good marks compared to the average value. So mostly, since in our case in mathematics, my result was 2A B's, so I went to engineering faculty. So in Ratnapura, you can go to medicine or engineering faculty if you have 1B, or that changes. Normally, the minimum result is 3A's. From 3A's you can go, but if you the mark of the B and the marks of the A are really higher, then you can go to faculty also. But from these results, 2026 batches results, they say that you would be able to go to faculties if you have 2B's also, A 2B, because most of the average of the students is not haven't covered the syllabus, and if you take second choice and third choice, they also have a little bit time remaining to get prepared. So the average value of the result is going to get reduced from this year. So what you have to remember is you have to cover the syllabus at time. Okay, so if you come to Asha Miriam's class, she's covering really fast. I mean, she's going to take 1 year and like 1 year, 2 months, I guess. Okay, within 14 months, she covers the syllabus. So the thing is, if you understand or not, that's your problem. Okay, she does the class. There are people who understand. In every batch, there are people who go with her flow, so they get passed out. If you are she's fast, or this class is fast, if you're going to leave that class, that's a real mess. Okay, every time go to a good class which is going to cover the syllabus. So I have planned to, so if you come to physics, it's really hard to cover the syllabus. The syllabus is really high in compared to chemistry, because you have a lot of the gap between O level and A level really high. So we have to train you all to A level to come and to get introduced to A level. It takes a lot of time. Understand? So covering the physics syllabus is a little bit harder than chemistry. Okay, so normally I said I'm going to cover the syllabus in 24 months, I mean 2 years, but have again reduced that. I'm going to cover the syllabus like in 1.5 year. Okay, so this is going to be a rapid speed class. So until mechanics, I'm going to go a little bit in a medium speed to take you all to I'm going to you have to grab the knowledge. After that, I'm going to do final lessons. I mean, if you take, there are 11 lessons altogether. While I'm doing the 5th lesson, I'm going to take the 11th lesson from back to front. After you go to the 5th lesson, it's a little bit easier to move on. The other lessons you can do by your own. Okay, right. So that's the plan. I have to remind you all that just be aware of the coverage of syllabus. Right. Now let's go to the next part. We covered the tan and sine curves. So we are going to go to the next part, page number 3. Page number 3. Let's see. So since I'm covering the syllabus a little bit fastly, if you miss one class, I mean 1 week, you are going to be in a real trouble. Okay. So I have sent all the recordings. Until now, I have recorded 9 classes continuously, and 2 classes from that only have been recorded, only the second part, not the first part. In one case, I corrected it. Now only one recording out of those 9 recordings have only the final part. I mean, not the first session after the interval. I have sent it. I sent that recording at last. We go to the group. You can watch it. So if you have any recordings to complete, just complete it now. If not, you are going to be in trouble. Okay. Right. Don't skip classes. Better to come physically. So what I'm going to do is, the thing I drew here, I say this is 90, this is 90. Let's take, this is 90. The next one is 180. This is 90. This is 180. This is 70, and this is 360. I'm going to draw that sort of graph here. This is a circular graph. Okay. So we call this part, we divide this, we take a circle. Okay, I'm going to draw a circle. Let's see if I can. Okay, circle is going to start from here. It's going to start from this point. So this is 90 degrees. So this is another 90 degrees. This is another, and this is another 90 degrees. Okay, so students, we call this part of a circle here as faces, as faces of a circle, faces of a circle, faces, parts. Okay, stages or phases. So this is going to be the first phase. Go from here to here. So this is the phase, next phase. This is going to be the second phase. Okay, this is going to be the second phase. This is going to be the third phase, and this is the fourth phase. How you go? Okay. Now what I'm going to do is, I'm going to draw triangles here. I'm going to draw triangles here. Let's take yellow color. Can I select this? A Benton watch, right? Okay. So I drew some triangles. These are some triangles, okay? Never mind, these are 90 degrees. And 90 degrees. 90 degrees. Also 90 degrees. Part. Part and this part, 90 degrees. Okay? I'll name this as theta, theta, theta. These are individual right angle triangles in 3 faces. Okay? Quickly draw this part. So before drawing, just tell me this. Okay, this is a graph. Okay, I drew some circle and faces in this graph. So every time this first face is the positive axis, but this part is the positive axis, and this is the positive axis of x, and this is the negative axis of x, and this is the negative axis of y. Okay, 1, 3, 4. Okay, so this is the positive and positive region. So this region is fully positive. Okay, so I'm going to mark this. This length in y is going to be in the y. We are going to measure that in from y axis. So this length is okay. This length is going to be positive. Okay, and if we take this length, we are going to measure that from x axis. That's going to be also positive, right? So if I come to this face, this triangle, this length I'm going to measure it from the positive part of the y axis. So that length is going to be positive. That length is going to be positive. But if I come to the adjacent side of this theta, that's going to be in the negative part of x-axis. Negative part of x-axis. So this length is going to be negative. Negative. This is positive. This is also positive, and this is also positive. Likewise, I'm going to see if these lengths are positive or negative. So again, if I come to this triangle, this part is going to be, we are going to measure this from this y-axis. That's going to be negative. Anyway, this is the negative part of y-axis. So this is going to be the adjacent angle, adjacent side of theta. That's going to be negative. And if I come to this side, this I'm going to measure it from the negative side of y-axis. So this is also going to be negative. This is positive. This is negative. All right. Understand? Okay. Now we are going to see the sign of sign. It is not this sign. This sign. But not this. Can you see this? Sign, the symbol, positive or negative. We are going to see the if the sine or cosine value is positive or negative in these regions. These regions. All right. So while you are listening this, you can complete this. Okay. Now you have here the first phase, the second phase, the third phase, and the fourth phase. So I'm going to give you the instruction for the first phase and a little bit instruction for the second phase. You have to complete the third and fourth phase. Okay, I'll come and take it in the sense I'm going to individual. So first I'm going to divide these regions. Divide these regions. So this is first. Okay, sine theta is equal to, how am I going to say sine theta in this triangle? In this triangle, opposite over hypotenuse. So hypotenuse is positive and this is also positive. Sorry. The green line there. Draw this. Okay. So here I have to mark this also. The hypotenuse here is positive, right? The hypotenuse here is positive. Here the hypotenuse is positive and here it is negative. So every time the hypotenuse here is positive. Is that statement correct? No. How are you going to find hypotenuse? If I give you the adjacent, the length of the adjacent and the length of the opposite side. That's the equation. Pythagoras. Okay. In Pythagoras, what I do is I scale the value of opposite and I scale the value of adjacent, and that's going to be equal to the length of hypotenuse squared. Okay. Let it be negative squared, let it be positive squared. Every time this is going to be, the result is going to be negative times negative, positive. Positive times positive, positive. Whatever it is, this final part is going to be positive. Okay. This final part is going to be positive. Final part is going to be positive. This final part is going to be positive. Let it be negative or positive, that's going to be positive. So if you add two positive figures, that's going to be positive. So every time in this case, not in this case, every time the hypotenuse is in a positive range. A positive range. So I'm going to mark that also. Okay. Positive, 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 positive. Now we're going to see the symbol of sine theta. Sine theta is going to be adjacent over opposite. So opposite over hypotenuse, opposite is positive and the So I'm going to teach you this first phase and I'm going to tell you to apply this to the second, third and fourth phase. So just look this and give a good focus. So sine theta, it's opposite over hypotenuse. Opposite is positive, hypotenuse is positive. I have marked that. If I go to cos theta, that's going to be equal to, again, positive over positive. Okay, positive over positive. This color, positive over positive. Okay, just put a bracket here. It's much better. So if you go to tan theta is equal to opposite over adjacent again. That's going to be positive over positive again. Okay. So finally, this sine theta is going to be, if you divide positive by positive, 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 that's positive. The sine theta between this 0 and 90 degrees is going to have every time a positive value. Understand? From 0 to 90 degrees, that's going to have every time a positive value. If you go to cos theta, from 0 to 90 degrees, that's going to be positive. Here, tan theta is going to be positive. So all of these three are going to be positive here, here, here. So I'm going to write it as all. Okay, right. Okay, so I'm going to write this second phase. Okay, so people tell me here the opposite side, if you go to this triangle, okay, this triangle, the opposite side is a positive value. Okay, that's a positive value. Every time hypotenuse is positive. Okay, so I mention it as positive. So if you go to cos, It's the formula of course is adjacent over hypotenuse. So hypotenuse is positive, but here the adjacent side is a negative value. So what I'm going to write is here I'm going to put it as negative. And if I go into tan theta, that's opposite over adjacent. That's going to be positive. Opposite is positive. Adjacent is going to be negative. Okay. So if I come to the solutions, here positive divided by positive, that's going to be positive again. Negative divided by positive, that's going to be negative. Okay, multiplication and division, that's going to be the same. So positive over negative, that's going to be again negative. So here only the sign part is positive. Only the sign part is positive. So I'm going to write here pink. I'm going to write here this is face is sign's face. Whose face? Sign's face. This is everyone's face. So here you have to mention third face is whose face and fourth face is whose face. I mean the positive angle, right? So I have given you all the steps to these parts. First and second phase, you have to find it for the third and fourth phase. Third and fourth phase. Hurry up. Soon, online people. Okay, just look this. Take this out. Okay, so I'll take a screenshot if you want the note. Okay. Okay. What's your name? Vihangan. So stop writing and just look into what I have done in here and here. Complete this. So you can complete the note after. So I'll give you time. First, stop drawing and complete the third and fourth phase. If you have drawn, that's okay. Third and fourth. Okay. Yeah, same pattern. Complete for these phases. If you have drawn, that's okay. If you haven't drawn, draw it later. Just do it for the third and fourth. Hypotenuse. 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 According to Pythagoras. Pythagoras in the opposite hypotenuse scale. Okay. So if take negative, what's the scale of negative? Negative, positive. So opposites negative scale is going to be positive again. And if you side, it's also negative scale. So negative is positive. So if you add two positive values, the positive. So let it be only the opposite side is positive, negative, or only the adjacent side is negative, or both are negative. The final value of hypotenuse is going to be every time positive. Okay, understand? Not face. Very good, man. This is PHAC. Okay, not face. This is face, right? E H A S E H. Got it. Max. Uh, Completed. With those same values. You understand? Okay. I have to remember how you did. Positive here. 10. All. Here on but science. This science. This phase is going to be Tan's phase. Going to be positive here. Positive. Now here, if you go to first phase, all three of them are positive. Go to the second phase, only the sign value is positive. All these three, so all this is going to be positive. Here, the sign. This sign's phase. Sign is positive. Okay. So if you come the two are negative, tan. Right here, tan. Only cos. All sign tan. All right. So you have. So what's the third phase? You did it. Is positive. Every time catch the pattern. You didn't do impatience. Hey. Not this. This. Yeah, no. Okay. Now mention here. First phase, sign is positive. Cos is positive. Tan is positive. Everyone is positive in the. So this is everyone's all. I mean all. Here positive. Now in this case, the phase. No. I asked which of this trigonometric ratio is positive. Only sign. So in this phase, sign is only the sign's phase. So if you go to this diagram, everyone has completed that. So the third phase here, third phase is going to be whose phase? It's Tan's phase. Tan's phase. Because in this region, from here to here, only tan is positive. So what are the angles here? More than 180, less than 270. 200, 200 degrees, 210 degrees, 230, 240, 250 until 269. It is the tan part is only the positive value. Only tan part has the positive values. Sine parts they have negative values. Cos parts they have negative values. Understand? Right. So if you go to this place, this is going to be whose phase? This was cosine's phase. I mean, only cosine values are positive in this region. This region. Okay. So this is from 270 to 360. So 280, 290, 300, 310, 320 until 359 is going to be only cos is going to be positive. Sine is going to be negative and tan is going to be negative. But once it reaches 360, that becomes 0. 360 becomes 0. So 0 in the sense it's going to be again in this phase. So here from this diagram you can't take the values that lie on this axis. Values of the ones who lie on these axes 0, 90, this 180, 270 or 360. Specifically you can't take the values of them if that is positive or negative, but you can examine the region in between. So these fixed values you have to remember. So sine 0 is 0, cos 0 is 1. Understand? So right, what we are going to do is we are going to do some questions from here. From this part I'm going to do some questions. So complete the third and the fourth phase. So it's going to be like here. So if you see this, I'll overwrite here. So in the third phase, sine, to take sine, the opposite is negative. This is negative. This is positive. Every time hypotenuse is positive. To take the adjacent side, that is going to be negative. Sorry, negative not, it's positive. Sorry, it's negative. Sorry. This is negative. So negative over positive, this is going to be negative and this is going to be negative. Here, this is negative and this is negative. So this is going to be positive. Okay. This is how the third phase will be. Okay. Fourth phase, likewise. So in fourth phase, you will get positive to here. Okay. Yeah, positive to here. So this is going to be positive over positive. This is going to be negative over positive. This is going to be so negative over positive again. So this is negative, this is positive in the fourth phase. Okay. Right. So I can go back. Rashid, someone to redo this. This is an old generation smart board. That's the case. Okay, this is the limit. So here I'm going to use this diagram and I'm going to move on to some questions. Okay. So before that, here the next page, let's just recall the part that we did do till now. So you have two axes. You have two axes. You have two axes, this and this, this and this, this, the big axis. Okay. So this region belongs to everyone. Belong in the sense all three of the trigonometric ratio is going to be positive here. I'm going to write the positive values. So in this region, who is positive? Who is positive? Only sine. I'm going to write it here. Sine. In here, third phase, only tan is going to be positive. Tan. And here, cos. So everybody is covered here. This is positive, sine, tan, cos, three of them are here, and here altogether they are here. Understand? So mention that part in this diagram. In page number 4, you have a cross-sectional diagram. Write all, put a cube, a box inside, and put a box inside. So these are the ratios that's going to be positive in those regions. After that, I have given you some space to write all sine S and T. S and C. Sine, cos, and are positive. Here, sine is only positive. Tan only positive. So here it's better to write only the capital letters other than writing the whole ratio. T and S. That's better. This is S, this is T, and this is C. Whole. Better to write. Okay. So in C, only cos is only positive. Write this. Write this there. Okay. Now I have given you three boxes there. Three boxes. One like this, one like one like this. This is what we have to write. Okay. You all know that in a triangle, if this is theta, this is going to be 90 minus theta. I have mentioned that in the triangle. Okay. So in this triangle, it's going to be ABC. Again, I drew it upside down. I'll draw it in the next. So this is theta. This is 90 minus theta. So this is A, B, and C. A, B, and C. Okay. So what I'm going to do here is I'm going to find the value of this angle, who 90 minus theta. Okay. So what I'm going to write is, first of all, I'm going to find sine 90 minus theta. This is going to be equal to BC over AC. BC over AC. Okay. Sine 90 minus theta is this part. So that's going to be opposite over adjacent, BC over AC. Right. So BC over AC, in the sense that's going to be the cos theta value. BC over AC. Is it? Yeah. Cos theta is going to be adjacent over opposite, BC over AC. So finally we can tell that sine 90 minus theta is equal to cos theta. Cos theta. Fine. Right. So I'm going to find what cos 90 minus theta is. So cos 90 minus theta is going to be AB over AC. Why? Cos 90 minus theta, AB adjacent over opposite. I'm going to find this value. So adjacent over opposite, AB over AC. When I know that sine theta is also equals to AB over AC. Why? Sine theta, opposite over adjacent, AB over AC. Right? So from here I can tell that cos 90 minus theta is equal to sin theta. So these are the relationship. Cos 90 minus theta is sin cos 90 minus theta is going to be cos theta. Cos 90 minus theta, that's going to be sin theta. So every time you take cos and sin, 90 minus theta is going to give the next trigonometric ratio. I mean, if it is sin, that's going to be cos. If it's cos, that's going to be sin. Understand? Okay. So I'll take this theta as 60. So 90 minus 60 is 90 minus 60 is 30. So sin 60 and cos not 60. Sorry, not 60. I took here 60 like this. So here if I take theta is equal to 60, then this is going to be sin 30. That's going to be equal to cos theta, that's 60. Understand? So if this is sin 60, this is going to be cos 30. Okay. So if I come to here, if I take 60 here, cos 30 is going to be equal to sin 60. Cos 60 is going to be equal to sin 30. Okay. So I'll ask you a question. Tell me cos 45 equals to sin what? Sin what? Cos 45. No. I'm asking this. So every time if I convert sine to a cos, if I convert a sine to a cos, what's the relationship between these two angles? You add up those two angles, that's going to be 90. Okay. So I gave you 45 here. I'm asking this angle. What's it? That's going to be 90 minus 45. Understand? Okay. So I'll tell you cos 23 is equal to sine what? Again 45. Can you see that? Wait. It's hardly recognizable. I'll use this color. I'm asking that cos 23 degrees is equal to sine what? 67. 67. That's going to be cos 67. Okay, understand? So this is going to be 90 minus 23. So if we take cos 55, that's going to be sine 35. You understand this relationship? So both of these rules tell that the exact same as this. Okay, this 90 minus theta. So if you take cos 55 is equal to sine 35, if you flip that, that's going to be this. Sine 35 is going to be cos 55. Okay, so every time remember that if you are going to have 90 subtract something, that's going to be the opposite of that trigonometry. Okay, so if you want to convert cos to sine, you have to subtract that angle from 90. Understand? Right. So if you want to find cos 55, you have to find the value of cos 55. But in the question, they have given sin 35 is 2.6. It's not going to be 2.6. It's going to be 0.785. But they are asking the question here. What are you going to do? Convert this to sin 35. This cos 55 is going to be equal to sin. No. I can write it step by step. I'm going to write this as this cos 55 is equal to cos 90 minus 35. That's correct. 90 minus 35 is going to be 55. Now I know that cos 90 minus theta is going to be sin theta. So this is going to be equal to sin 35. So now they have given that sin 35 is 0.75. So cos 55 is going to be equal to 0.785. 785. Understand? Okay, everyone? All right. So not, don't write this in the book. You're going to write that in this box. Something else there. You start writing this part. Who? You start it. Don't write this part. Don't write that part. There's something else. This box, you have to write this. Select this. Here you're going to write this. Tan. You're going to write about tan. So we know that sine theta is equal to what? Sine theta is equal to AB over AC. AB over AC. Okay. So I'm going to divide sine theta by cos theta. Cos theta is going to be equal to DC over AC. Okay. So from here you can cancel this to this. Why? Because that's divide relationship. Okay, I'll tell you. So if you want to have a brief explanation on this is like this. Okay, AB over AC. Okay, this is divide. Okay, this is DC over AC. Okay, five people you can write this here. So what I'm going to do is I'm going to write AB over AC like this and put a bracket here and put a division mark here and write DC over AC. Okay, fine. What's the next step? AB over AC is going to be the reciprocal of this, AC over BC. So here you can cancel this. So the final answer is AB over BC. All right. So this is what's going on here. Here. So now this is AB over BC, AB over BC. You know that AB over BC is going to be tan theta. So this is equal to tan theta. Just look here. AB over BC is going to be tan theta. So tan theta is equal to sin theta over cos theta. Cos theta, sin theta over cos theta. Write this part in the last box. Okay. There are some other formulas in trigonometry that you will have to know. So when you are going to those parts, I'll let you all know. Okay, there are a hell lot of equations. Sin squared plus cos squared equals to 1. Sin 2 theta equals to sin theta cos theta. Right. Now I'll give you a small exercise. Take your notebook. I'll give you all the break at 10:20. So we start a bit late. Okay. So write this sin 8. Write this in cos form, and 926 cos 54. Write this in the next trigonometry. Cos, you have to write that in sine. I'll give this as 46. Okay. After that, there's a triangle. Okay, a right angle triangle. This is root 3 ABC, 30 degrees A. Okay, I have to give you a little fact that you have to know. Go to page number 1. Write this soon. Go to page number 1. Okay. So you have to know these values. The value of root 2, the value of root 3. Every time value of root 2 is going to be 1.414. Okay, in LL you take this. Root 3, that's going to be 1.732. Okay. So you are going to take 1 over root 2 as 0.707, and 1 over root 3 is going to be 0.577, 0.577, right in the first page. And these things you have to remember. This is highly important. You have to remember this stuff. Okay. Apart from this, you have some additional square roots. Square root of 5 and 10. Square root of 5 and square root of 10. 5 is going to be 2.23, 2.23, and 10, that's going to be 3.16. Write these additional parts. One over root 2 multiplied by 2. Yeah. Sorry. I have to multiply 0.577 by 1.732. So you don't get 3, you get 1. Root 3 to root 3 cancels off. 1 over root 3 multiplied by root 3, that's going to be 1. Multiply 1.732 by 0.57, that's going to be 1. Okay. You have a calculator. 1.732. No, this is approximate value. Okay, so that's not going to be exactly 1, because these are rational numbers. Okay? So they have infinite decimal. For A levels, we just round it off. Okay. Right. There's an additional part here you have to know, but the explanation for this is not related in physics. It's related in maths. So I have to take a maths class here. Otherwise, so I'll let you all know this thing. You have to write this in the page number 4, where I gave you the 90 minus theta stuffs. Page number 4. Okay. You have space there. Page number 4. Okay. In here you have some space there. You write all those stuff, all sine, tan, and those things. Have space. Between that, there's a triangle and a rectangle. There's a triangle. There's a triangle and there's a rectangle here. So you have some space here. So there you have to write this. This is that you have to write here. So sine, I said that sine 90 minus theta, 90 minus theta is going to be cos theta. Okay, right? But here we take sine 180 minus theta. That's going to be sine. Okay, every time that's going to be sine. If we take cos 180 minus theta, that's going to be a cos value. Okay, so from this, write this, and I'll tell what are the things that's going to come here. So here, write that theta is less than, greater than 0, less than 90. Greater than 0, less than 90. Okay, this theta is greater than 90. So we are going to substitute something in between this. Okay, you can't substitute 110 here, right? So write this information. So this is the thing that you have to know. Okay, so multiples of 90, 1 time 90, 90. So not multiples of 90, how to tell that? Even multiples of 90. Even multiples in the sense you are going to multiply this by multiply this by 2. Even multiples of 90, that's going to be 180. Okay, not 3 times 90. Next you are going to take 4 times 90. That's going to be 360, and 6 times 90 likewise. So 2 into multiples of 90 every time. You take inside a sign value 90 minus or plus, let it be minus or plus. Every time the value is going to be cos. Every time the value is going to be sine, the exact one, sine. But if it's a multiple, I'll write here. This is an additional part you'll want to know. Okay, this is an additional part. So I'll write here even number. Okay, you multiply this by an even number, not 0. That's also visible. 0 is an even number, right? So if you multiply that by 0, that's going to be final is going to be 0. Okay, if you multiply this by 2, that's going to be 180. If you multiply by 4, that's going to be 360. Okay, even multiples of 90, if you take the sine value or the cosine value, (180), right? This I'll name it as alpha. For now, I'll explain you all. This 180, take it as 180. So this is going to be sine something. Okay, if this is cos 180 plus or minus theta, this is going to be cos something. Okay, but if you come to uh, 90s odd multiples, odd multiples, odd numbers. If you multiply them by odd numbers, the final value is going to be, you multiply that by 1. That's going to be 90. That's going to be 90. So you multiply that by 3. That's going to be 270. Okay, 270. Multiply that by 5. That's going to be 370, 450. Understand? So whatever the multiples of this, for now I'll consider it as 270. 270. I'll take this color and separate this by a line. Okay, got 2 parts. Right. So here, if this is sine, let's take 270 for example. 270 plus or minus theta. Now if you have an odd multiple, this is going to be the cos value of this. Okay, cos value of this. Let it be 90. I say if there's 90 here, it's going to be cos something. I say that. So if this is cos something, for now I'll take 270. Don't write it as 270. It's going to be sine something. Sine something. Okay. So instead of these 270s, I'm going to put alpha. I'm going to name it as alpha. I'm going to name this part as alpha. Okay, alpha. This alpha. This alpha. Okay, and here I'm going to name this as. Here I'm going to name this as gamma. Okay, this is gamma. Okay, wait, don't start right. Still don't start right. So the examples for this is, let me write that in yellow color. Example for this is 180. I'll start it from 0. 0, 180 and 360 and so on. Okay, example for this is 90, 270 and 450 and so on. Now for this. Okay, now this is going to be alpha and this is going to be gamma. Going to be gamma. Okay, now if you have something multiple 180, the multiple that's on this straight line, if you take this graph, you take the graph like this is 0, that lies on here, lies here. The next multiple is 2. 2 times 90 is 2 times 90 is 180. Now that that angle lies on this from here 180. So I multiply this by the next even number 4. That's going to be 360. Now that lies on this side, right? Now I multiply that by 6. That's going to be 90. This is a 90. This is a 90. This is 2 90s, 3 90s, 4 90s, and 5 90s. So that's going to lie 1 revolution after that. So you are going to go to 360 and again come to here. Starting by here. You are going like this and coming to here. Understand? And that lies again on this axis. This axis. So every time this part lies on only this straight line, I'll mark it in blue color, that lies on this line, this part. So if an angle is made by adding or subtracting another angle and this gamma is going to lie on this part, let it be 180 or 360 or multiples of that, then what happens is the next part is going to be the same angle, same trigonometric ratio. If that is sine, this is going to be sine. Okay, now if you come to this part, since we multiplied this by let's take green color here, multiply by an odd number, this is going to be this is going to lie every time on here. So if we take 90, 90 is here. If we take 270, the next one is going to be here. 450 is going to be like this and come to here. Understand? So every time that's going to lie on the y-axis. Understand? So this is going to be the y-axis and this is going to be in the x-axis. So I'll write like this here. Oh no. Okay. So I'll write it like this. As a short note, I'll write this as lies on which axis? X-axis, x-axis. And this lies on y-axis. Okay. I have to write this part. So select this whole board and till you can see this thing. Okay. So can you copy this down? So you should be copy this down in your notebook. Do you have a notebook? Oh, better if I can zoom. I'll erase. Okay. Soon. I'm going to do some exercises from here. Okay. Now I'm going to do this. Sine 120. I have to find this. Okay, do you know this? No, you don't. Don't know the value. What I'm going to do is from here, page number 5. So here I have a rule to convert sine into sine. Okay, so every time this is going to be something. This is going to be here. You are going to have theta. Okay, here you are going to have theta. But why I didn't write here is we know that here the theta is going to come, but the symbol is unpredictable. I mean, that's going to differentiate with this gamma. Okay, so what I'm going to write here is I'm going to write here plus or minus. So plus or minus, plus or minus, plus or minus. It can be plus, it can be minus. Okay, that depends on this alpha or gamma, right? Note it down also. Plus or minus theta. So here I can shrink this alpha into a theta value, a small part. So now what I'm going to do is, so this gamma should be a multiple, even multiple of this 90 degrees. So even multiple, the smallest even multiple is 0. The next one is 180. So what I'm going to do is, I'm going to find the nearest second multiple, not second. I'm going to find the nearest even multiple of this, multiple of 90 to this 120. What is the nearest multiple? 0 or 180? Which one? That lies on which axis? That lies on the x-axis. I said this rule, sine converting to sine, lies on the x-axis. So the x-axis, the angles that lie on x-axis between 0 and 360 is 0 and 180. So the nearest one is 180. So what I'm going to do is I'm going to turn this part in sine. I'm going to write this in sine 180 plus something or minus something. Okay, so 120 is less than 180. So I have subtract something, or should I add something? I should subtract. So what I'm going to do is I'm going to write this as subtract. How much should I subtract to make 120? 60. Okay, I write it like this. Now I'm going back to the rule. Okay, I'm going back to the rule. So that says that if it is plus or minus theta, that's going to be theta. So 180 minus theta is going to be theta here. I mean, I put here, substituted here 60. So here it's going to be plus or minus 60. What's it? Plus or minus 60. Plus or minus 60. So I'm going to write this. This is going to be sine 60 plus or minus. I don't know, it is plus or minus. Okay. Now what I'm going to do, I'm going to go to page number 4 again. Okay. So this 120 lies on which face? Which face? First, second, third, fourth, or which face? First or second or third or fourth? 120. 120 degrees lies on first face. First face. 120. First face is between 90. 0 to 90. So 120 is going to be the second phase. Understand? In the second phase. So here I know that sine 120 lies on the second phase. So check and tell me in second phase which trigonometric ratio is positive. Sine. So sine 120, the value of sine 120 should be positive. Okay. So you all know that sine, you all know that sine 60 is going to be what? Sine 60. What's the value of sine 60? That is go to page number 1. Sine 60. So cos 60 is half. So sine 60 is going to be not half. That means root 3 over 2. Okay. So this is going to be root 3 over 2. But I don't know if this is plus or minus. But I know that the value that's going to be obtained from 120 is going to be positive. Why? That's in the second phase. So here I am going to put that this is positive 1 root 3 over 2. Okay. So what I do here is I'm going to write this here, and here I have to change something. I just remembered. Here. So you wrote plus or minus here, ne? Plus or minus. See right here. Forgot it. See right here. So it's not here. This plus or minus is not inside this. That's going to be here. In front of this. Plus or minus. Just reach it. Rewrite that. Plus or minus is not in front of this. In front of this. In max, you write in front of this theta value, but to simplify that, I'm writing that in front of here. If the theta is inside, if the plus or minus is inside theta, it's going to be really hard to understand because that's the maths part. Okay, don't do that. So that's why here I didn't get to the answer directly. So here it's going to be, let's go to this part. This is going to be plus or minus sine 60. Plus or minus sine 60. Okay, I don't know this value. I don't know plus which or which. So, but I know that sine 60 is going to be root 3 over 2. So, to decide this plus or minus value, I'm going to check sine 120. Where does that exist? That exists on the second phase. So, this is going to be positive root 3 over 2. Understand? Okay. So, this is how you come to the answer. That's why I wanted to change that. It can be inside theta, but that's a little bit complex. That's for max people. So for bio people, you have to write this plus or minus in front of the trigonometric ratio. So there's another way to do this by using cos. Okay, I'll explain that and give you the interval. Okay, don't worry. So I'm going to write this 120 like this. I'm going to write this sine sine 120 in the terms of cos. So I should use odd multiples of 90. So the nearest odd multiple is 270 or 90 degrees. 90 degrees. So I'm going to write 90. Okay. So to make 120, I should add or subtract. I should add. I'm going to add how much? 30 degrees. 30 degrees. So I'm going to add this 30 degrees here. So now I know that. Every time if this is 90 plus cos 90 plus 30, that's going to be not this. I'm expanding this. Okay, I'm expanding this. This again sine. I just wrote this 120 like this. Okay, that's the step I do here. Now I'm going to do the second rule. When it is 90, this sine is going to convert into cos. and the theta is going to come here, but I don't know if this is positive or negative. Okay, positive or negative. So what I'm going to do is I'm going to decide that decide this the positive or negative value from this sine 120. So again sine 120 is positive. So I'm going to mention that positive here. We can write that positive or minus here and come to again to this value, or we can write positive here also. So we are going to find the symbol in the second step, not in the third step. So this is much easier. So from here I know that cos 30 is cos 60 is equals to half. So cos 30 should be the next part. It's root 3 over 2. So again I come to the answer root 3 over 2, and this is the exact answer that I got here. Okay. So just copy this in the notebook. So I'll give you some values. You should find them. Do it as your homework. Okay. Right, soon. So in your notebook, after you're completing this, write these values. You should find these values. Sine 150. First question, sine 150. Sine 150. Second, sine 135. Sine 135. Third, cos 120. Cos 120. Fourth, cos 135. Cos 135. Cos 135. In your home, do this part. So first of all, what's the step? You have to find the nearest multiple. If you are going to find the value from the same trigonometry, you are going to use that first rule. If you are going to find it from the opposite trigonometry, you are going to use the second rule. Okay. If you are going to find from the first rule, you are going to find the nearest second multiple, I mean even multiple of the 90 degrees. If you are going to use the other trigonometric ratio, you are going to find the nearest odd multiple of 90. Okay. After that, you have to write this, expand this by adding or subtracting it to the number, to the multiple of that 90. Understand? After that, from those rules, this theta is going to come here. Since this is 90, even odd multiples, this sine is going to convert into cos. But here, since this is an even multiple, sine is going to come here again, sine. Understand? So those are the steps. After that, you have to find this value from the table and substitute it. But before that, you have to know if it is positive or negative. So you have to search that part from the table. Okay. So I'll give you some more questions. So find this. Sine 315. Okay. Cos 'cos, sorry, this is not equal sign. Sine 135 and cos 225. Okay, raining heavily. So you're going to have holidays again if it's going to rain like this. Okay, because this Ratnapura, the floodiest. So write it here. I'll give you some more examples. 180. Uh, 210 of sine and cos again 210. Find these values. So this is going to be the 5th, 6th, 7th, and 8th. This is enough. Let's try then. Okay, fine. Have your break. It's going to be 15 plus or minus 5 minutes. So if I come before that, you have to come. If you come after that, you have to come. So we are going to move into vector parts. Have a break. But it's raining me. Can't go here. Is there flooding these days? Is Balangona flooded? No. What's the name? The river's name? Sure. Okay. That's the next online student. Just go. Probation. Okay. So the LL exam was in February, right? February this year, last year. This year, ne? This year February. Sure. So the next batch is going to sit on December. December, right? December or August. Usually all LL is on December. So I think they have only they're going to sit earlier. This 2026 batch. Okay, so recorded. Okay. So I said I will bring you all Pesuru, right? So Pesuru books, I explain what a Pesuru is. Those are they are the only publication who classify the exam questions, past paper questions into unit wise. Unit wise they classify. So since the A level 2025 fifth batch wrote the LL in this February, they have to collect those papers and write answer schemes as well as classify them. It's a big process. So the Pesuru books are out of stock. I mean the old Pesuru books until 2024. Until 2024 exam questions, the Pesuru books which had those until that paper is out of stock. So they are going to publish them on the next coming month, the final part of this month. So I'm going to take books from them and give you all here. So if anybody, so don't take books. There are no books anywhere. Facebook, you can't take it anywhere. I searched all around and they say, I called the publication and they say they will publish them on the next month. Okay. From next month, I'm going to, I'll put a message in the group. So if you are willing to buy MCQ structured OSA, just drop me a message. I'll put a poll and I'll ask who wants those papers. So since this is a class, they are going to give it for a price. So I'm going to give you all in a lower price than the mark price there. Okay. So other than taking from bookshop, you can take it here. Okay. So it's going to be not a big difference. It's going to be a little bit different for students. Right. So I'll put the amount price and you have to I'll take the orders first and I'll bring. If not, after I bought it, if you didn't buy it, it's going to be a loss. Understand? Okay. Right. So we are going to move into vectors. Vectors. So for vectors, I'll tell you a small story. Okay, that happened. Okay. Great. In my A-level times, so I was going to a maths class. Okay, a female teacher. So I had a friend. I said a friend who was a little bit crazy, and he's a little bit brilliant and a little bit crazy. So one day we were after classes. So after classes we were waiting for bus. We were going in the direction of Ahaliyagoda. So this is between, this is Ratnapura and this is Ahaliyagoda. Okay, we were in between here. Okay, in some place here. So we were waiting for bus to go in this direction. Okay, so we were waiting and waiting and waiting. So that day, due to some reason, there was no buses. I mean, from this to go in this direction, we have to go in 99 or 122 or 98 Colombo buses, because he was in Avisal. I was here in B. So let's take it as Avisal. AR. Avisal. Okay. You all know Avisal, right? Okay. So there were no buses, but he saw that many buses go in this direction, 99, 99 in the sense that's Colombo, Badulla Colombo, and 120. I just remember the numbers. And 98. These also Badulla Colombo and Badulla Limited. Those buses are going this direction. So he was just standing there. We were both standing here. We were both standing here looking in this direction. Okay. So we have to go in this direction. Where? To Avisavella side. But the buses were in that direction. So we were waiting. I was wondering, these buses are going there, and could we wait until they go there and catch the buses again and to come? So then suddenly this crazy man said, now there was a bus coming from here, from Avisal to Ratnapura. A bus was coming. So he said, I'm going to go in that bus. Suddenly he said, I'm going to be in this. I said, don't talk BSS. You're going to go to Ratnapura, right? You have to go to Avissal, and you can't go to Ratnapura and take a bus from there. So he said, no, I'm going to go in that bus by taking a minus part. I mean, he said that I'm going to multiply that bus by negative, and I'm going to get in that bus so I can go to the Avissal. So I didn't get it, what he was telling. What he was telling was the thing that's going inside vectors. Okay, so this bus that was going in this direction, he said that he's going to multiply this by negative and he's going to get into this bus. Okay, but what does that mean? Just multiply by a minus, not a digit, just a minus. Okay, these are properties of vectors. So the difference between vectors and scalars is, what's the difference? The difference, scalars have only a magnitude, but vectors have a direction. So you can, if you have direction, you have to consider both the direction as well as the magnitude. So in the lesson vectors, we are going to look into the parts where we can see. So you know to add 1 plus 2, right? It's a magnitude. 1 plus 2 is going to be 3. But if you are going to add two vectors, which is 1 and which is the value magnitude is 2, but the direction is somewhere this side and somewhere this side, you can't just add these two and put it as 3. Okay, this is going to be something else. This can be 1.6. Can be 1.6. Okay, so now we are going to see how to do operations to these vectors. Operation is, we are not going to do a surgery to these vectors. Okay, operation is multiplication, division, subtraction, and addition. So if we come to vectors, if we come to the topic vectors, we are going to do only these: multiplication. Sorry, let's start with addition, the easiest one. We are going to do addition, subtraction, and multiplication only. Division is not defined in vectors. We can't divide vectors. Okay, right. So let's go to the example again. So we were there trying to go in this direction, but the exact vehicle was going in this direction. So in vectors, if we multiply any vector by a negative mark, okay, just a negative mark. So this negative mark, I have said that you have a number here, but you can't see that. What's that number? 1. This is 1. So you are multiplying this by negative 1, not just negative mark. So this value is going to be multiplied by 1. So there's no indifference. 2 multiplied by 1, that's going to be 1. 2. 3 multiplied by 1, that's 3. 4 multiplied by 1, 4. 5 multiplied by 1, 5. So the magnitude is not going to change here. But since we are multiplying this by negative, okay, this direction is going to be flipped. Okay, this direction is going to be in this direction. Okay, so I can't remember that YouTube channel. I'll recommend you a YouTube channel. So next time, I hope to put some QR codes in the tute, so you can scan it and look those videos in YouTube. So I hope to do that. But let's see if I can do that. So in those videos, what they do is a man is walking in this direction. Just it's a cartoon animation. Okay, a man is going in this direction. So a man comes here, takes a gun. Okay, takes a minus mark from his pocket, put it inside the bullet and shoot it. Okay, once that minus comes to this man walks in the next direction. Okay, that's to explain these vectors. Okay, so just remember that there are several types of vectors and there's a method to represent those vectors. So how are we going to represent one? Yes, we are going to write 1. To write 10, you are going to write 10. But here, not only the magnitude, in vectors we are going to see the direction. So this is how we write the directions, represent a vector. Okay, this is how we represent a vector. So we were in Ratnapura. Assume that I was in Ratnapura and I want to go to Avissal. Okay, so I'm going to start and I'm going to put an arrow. So I'm going to go in this direction. Okay, right. I'm going to explain something else by using another scenario. Okay, So take two buses. Okay, let's do two buses. No, let's take two cars. Two cars. So which is faster, Porsche or Lamborghini? No, that's right. This with let's compare this with BM. This is faster. Let's take this Porsche 911. This is going to be fast. Right? This is a racing car. So let's take this general BMW, just like i7. This is not a race car. Okay. So let's compare these two cars. Okay, just girls will don't know these names. Just think these are cars. Okay, two cars. I'll draw this in blue color. This is a small, slower car. This is a little bit fast car. Okay, I'll draw that in red color for your understanding. Okay, this is a faster car. So these two are going starts the engine rev and they start moving. Okay, they start moving. Okay, now I am here taking a camera, take a video, post it out, and giving my camera, and I'm telling 1, 2, 3, and they start to go. Okay, now which car is faster? I say this red color. This one is much faster. Okay, so normally when it's here, now I'm going to take the picture. I just made some decision, marked a line, and when it's going to pass this line, I'm going to take a shot. Okay, but the thing is, the camera that I'm using is a little bit cheap quality camera, so the frames per second is going to be really low. Frames per second, that's a specification of a camera. Okay, so have you seen that if you take a picture of something moving, that picture is going to be like this. Take a ball, it's moving in this direction, you take a photo, that's going to be like this. Have you seen this? Okay, have you seen this? So when the frame rate of a camera is going to decrease, this blurry thing is going to this is going to increase. So if you take a photo of a moving ball from a higher resolution and higher frames per second camera, you can see that ball is like this. And still this is moving, but you can see this. But let's take this, we took this from a 70 something. If you take a photo from a 50 or something, this is going to be like this, a little bit, a tail is going to be there, attached. So if you take it from something like this, like let's take, I'm using here a 10 frames per second camera. So the tail is going to be longer, much longer. Okay, it's hard to capture those type of motions. So when these two cars are starting to cross this line, I'm going to take a photo. Okay, so let's assume that these two cars passes this line at the same time. Okay, at the same time, but these two have different velocities. When I'm pressing the button in this line, and when I'm taking my hand, these two cars are here and one car is here. Right? These two have different velocities. Okay, then if you compare those two pictures, what would be it like? One picture would be like this, something like this. No, let's take one picture would be like this. Stop talking. One picture would be like this, and the next picture would be something longer than that. Right? That's correct. Is it correct or wrong? If you compare the lengths of these two, the faster guy is going to have a big length, the span of the picture. Okay, understand? So when the magnitude here, what happened here in this car? This is much, it has a higher velocity. So higher velocity in the sense, the magnitude. Is the direction of these two cars same or different? Same. Direction is same. What's the difference? Just the magnitude. So the magnitude of this car, let's take this as this moves in a speed of 911. Okay. So this moves in the speed of 700. Okay. So this is 911, this is 700. So this magnitude is greater than this magnitude. So if we take a photo, we take a picture, it's going to be like this. Okay. This is going to be short and this is going to be longer. And if we take the exact photo, let's assume this. You see, you are going to miss this part. Okay, don't talk. Let's take this as 4. The speed velocity is 4 kilometers per hour. Shh, don't talk. This is 2. Then if we compare to both this length, which length? This length, let's take it as x. This length, let's take it as y. This y would be half of this x. This x would be double of this y. Why? The ratio between these two is 1:2. So this length is going to be exactly like that. Okay. So this is how you represent a vector. Did you understand? Did you understand? Okay. When the magnitudes are going to different, it's going to be a little bit different, then the representation of a vector is going to be different. Okay. This is how you represent a vector. Okay. Now let's come to the our lesson. So these are the examples, and now we have the knowledge, the summarized knowledge of vectors. Only this now we can this is that much simple. I don't want to explain this further. Just I explained everything. Now we are going to write the notes. That's all. That's what a vector is. After we can go to addition of vectors and subtraction of vectors. Okay. Move on to page number 5. Move on to page number 5. Okay. So first of all, to give a little bit introduction, I have mentioned every part. You can read it. Physical quantities can be divided into two categories, namely vector quantities and scalar quantities. You all know that. Scalar quantities, a scalar quantity is completely specified by its magnitude. A scalar quantity just only have a magnitude. Example, mass, time. Do you have a direction for mass? Do you have a direction? No. If you are confused mass with weight, that's your problem, okay? Mass is a scalar, weight is a vector, weight is a force, okay? Right. So time, it doesn't has direction, distance, pressure, energy, density, speed, and area. Okay, read them. Scalar quantities can be added mathematically. Mathematically, you can add them, right? 1 plus 2 is 3, 3 plus 4 is 7. Understand? But for vector addition, the direction must also be considered. For vector addition, you have to consider about the direction. Also, usual other mathematical calculation can be applied for scalars. Usual mathematical operations can be applied to scalars also. Multiplication, 2 multiplied by 3 is equal to 6. So if you multiply a scalar which has 2 magnitude, a scalar with a magnitude of 3, the final output is going to be 6 scalars. Okay, right. But it can't be applied directly for vectors. So those mathematical operations that we use in the day-to-day life, we can't put them for those vectors. It's a little bit different. Okay. Scalar quantity, it should be vector quantity, right? Yeah. Change it as vector quantity. Oh my god. Change it as vector quantity. In page number 5, you have the same topic twice. It's going to be vector quantities. Vector quantities. They have both magnitude and direction. They have both magnitude and direction. Obey the law of vector addition. Obeys the law of vector addition. There's a law, okay? Displacement, acceleration, impulse, momentum, magnetic flux density, velocity, force, electric field, etc. Those are the examples. Okay, if you want, you can just search about them. Okay, now let's come how we are going to represent a vector. Okay, so a vector can be represented by a line segment geometrically. So in vectors, if we are going to represent it geometrically, we are going to use a line segment. Line segment in the sense is going to be just a straight line. Okay, right. The length of the line is proportional to the magnitude of the vector, and direction of the arrowheads shows the direction of the vector. So is this representation correct? So let's assume that this x is twice of y. Okay, I drew it like that. Okay, so what are the points? They say that the length of the line is proportional to the magnitude. So this is proportional to the magnitude. So let's take 2 is represented by this line. So 4 is represented by this line. And I made a relationship. Okay, just think this is half of this. Okay, so it is proportional to the magnitude. Fine, proportional to the magnitude. And what I have, the next part, magnitude of the vector, and the direction of the arrowhead shows the direction of the vector. So there should be an arrow, but is there an arrow here? No. So you can't represent a vector like this. So the next part you have to add here is you have to add 2 arrow marks in the direction which is going. Okay, so this don't want to be in the same starting point. It can be in different starting points, but the length should be proportional and the direction we should mark that in by an arrow. Right, fine. So I have a small space, so I'm going to give an example. Just write it in small letters. In that space, there's a space. You have to write the example as well as you have a diagram to draw. So manage those space. Okay, manage those space. Write the example. Write the example. Example. A velocity of a velocity of a velocity of a velocity of. Unless you're going to hear me now. Okay. A velocity of 50 meters per second of 50 meters per second in the direction of north in the direction of north direction of north direction direction of north east. So you write north and capital letters, right? Northeast direction. It goes in the northeast direction, and you have given that scale 1 centimeter is equal to 10 meters per second. 10 meters per second. 10 meters per second. Right. You have to represent this. A velocity of 50 meters per second in the direction of northeast. Now you have given the magnitude. You have given the magnitude as well as the direction. So northeast. What's the direction? North, and this is the east. I'm going to write this. North and east. So northeast is going to be somewhere here. Going to be 45 degrees in an angle. Okay. Horizontal. Yeah, almost. So this is my vector, and before you write, you have to use a ruler, right? You have to represent 1 centimeter for 10 meters per second. Okay, so here you have 50 meters per second, 1 centimeter, 1 centimeter is equal to 10 meters per second. So 50 meters per second should be equal to 5 centimeters. Okay, so take a ruler, draw these two lines and measure 5 centimeters from your compass, or just keep the ruler here and draw a line and draw an arrowhead. So this angle you have to mention it. It's going to be 45 degrees, and the length is going to be 50 meters per second. You don't write 5 centimeters. Length is 50 meters per second. Why? This is a vector, not just a line. Okay, right. This is how you represent it. After that, you have to mention this symbolically. Okay, now this is not enough. We have to know the reference point. We should have a reference point every time. So what I'm going to do is I'm going to name this as A starting point and this as B. I have to name the places. Okay. If you are going to draw this as in a graph, you are going to start it from the origin. Okay. Hard to scroll. Have to pan it. Okay. A vector quantity, the next second point, a vector quantity acting from A to B is symbolically expressed as, and this is symbolically expressed as like this, A, B, and you have to put an arrow on the top of it. This is how you represent this symbolically, right? When the magnitude of this vector quantity is A, if the magnitude of this vector quantity is how much? This is 50. Now they say that this is going to be A. So we represent that as, so now in the third point, we represent it as simple A. Is it? It's just a magnitude. We have to tell that this is a vector. You have to tell this is a vector. So what we do is we just underline it. Okay? We just underline it when you are writing by your hands. But when you're printing it, you're going to bold the letters. So whenever you find a bold letter in a printed document, I mean, not in just English grammar or something, I'm mentioning about vector lesson in physics or mathematics books. If they are showing something in bold letters with nearby an arrow, that's going to be a vector quantity. Understand? That's going to be a vector quantity. So you can write that part also. Printed materials, it's going to be bold. Written, it's going to be material. We have to underline it. Line. Okay, write it here. This is for the big space. After that you have some point. This is the third point, and within this write this part within this. So your paper is going to be a written one, right? Your question paper is a written one, not handwritten. It's a printed document. So whenever they mention a vector, they are going to bold it. Okay, so you have to be careful. So you're passing these. Now it's a little bit harder, but when you're going almost 2 years, it's going to be really easy. You are going to get familiarized. So don't, but these days you have to be a little bit alert, right? Still you are just practicing in your practice learning. Every time when you see a letter which is bolded, that's going to be a vector. Fine. So now, max people, I think you will also need to this part. This is how you mention, this is a vector. This has a magnitude as well as a direction. So to mention this, I can't just write this as an A. This is a magnitude. Yeah, but to mention this magnitude is of a vector's magnitude, we are going to express this as in between two modular signs. Okay, so this is how we express it. So this can be equal to A. This is the magnitude is A, but to tell this is the magnitude of the vector, we are going to write the vector and put this between two straight lines. So this two straight line is known as, this two straight lines, this and this is known as modulus. Modulus. So max people, you are going to come to this lesson in a few days. Modulus. is known as modulus. So the meaning of modulus is if it is a negative value inside the modulus, the final output is going to be a positive one. If it's a positive one, again it's going to be a positive. So what does a modulus do is it excels the sign in the sense the direction of the particular quantity. Okay, so if there's a direction in that quantity, the modulus is going to delete that part. Understand? So if a bus is going, the bus is just going to go in every direction. Okay, it doesn't have a direction. You're going to put that inside a modulus sign. Okay, again you call this as, I can't remember the next part. There's another name to call this symbol. Okay, so here you have to write this in the third point, this, and if you have AB, you have AB here, you have AB here, AB equals to AB. This is the magnitude, but we have to mention this is a vector. How? We represented this with an arrowhead. Okay, arrowhead, fine. But this is equal to magnitude. So how am I going to avoid this particular AB's direction? I have put it inside the modulus sign. Just one arrow, not double arrows. I just over it a line here. So this is just a one arrow to mention these two things. This is how you represent a vector's magnitude symbolically. Understand? So this is really easy. So when the thickness of the font is going to decrease, the clarity of the image is going to increase. Right? Okay, fine. Now we are going to the next part. Vector geometrically representing. We are going to represent that. Vector geometrical representation can be shown as below. So you can represent this vector geometrically in a way we represented it in here. Again, we can represent it like this also. So let's take something is moving in this direction. We are going to put an arrow, the magnitude, the arrow, and the starting point and the ending point. Okay, so I have to mention the length of this is going to be this length plus the direction. This is a vector quantity. Okay, and I can again mention this in a way that the same exact vector starting from A and finishing at B, but now the value is, I can represent it in this part up, underline. Okay, this is how we express a vector. So write that down. These two should be equal in length and parallel to each other. Why? The direction is same. Okay. I don't believe in him. You don't? That. Who do you believe in that? So you believe in aliens. That was the shit. Is it? Who? Who say that? Okay. So there are, if we come to vectors, vectors, there are different types of vectors. Okay. Equal vectors. Equal vectors. So this is like a subject in grade 5. You learn about fractions, equal fractions, unit fractions, mixed fractions, proper fractions, improper fractions. This is how you come to a, when you're coming to a new topic, you're going to learn this stuff. It's going to be boring, but those are the basics. If you have the basics, you can learn whatever after that about that exact topic. Okay, so part by part we are going to fill the cup. Okay, so equal vectors, equal vectors, equal scalars. What's the meaning of equal scalars? Just tell me example for a scalar. Scalar quantity, mass. Let's take a mass. Okay, now I have a 5 kilogram ball, a metal ball, 5 kilogram. Okay, a pot shot or something, 5 kilogram. It's not 5 kilogram, 25 or something. No, not 5 kilogram. Okay, a 5 kilogram ball, right? So I want to make an exact scalar quantity which is equal to this scalar quantity's magnitude. This only has a magnitude, right? Okay, I want to make something else. So I can make a solid, a cube with this exact mass, but I can keep this one, this cuboidal shape something which is 5 kilogram in Jupiter or in Mars, whatever the planet. So if we take the weight, this is Earth and think this is Saturn or something, I'm going to keep this. So the direction is going to be like this. Can you see this? I'm sorry for drawing this a little bit smaller. So if I'm going to keep this mass here, the weight is going to be in this direction towards the center of this Earth. So if you're going to keep this object here, this is going to be in this direction. So this direction is the weight, the direction of the weight. So weight is a what quantity? Vector quantity. But if you take the mass, you can tell that mass of these two objects are equal to each other. But if you take the weights, weight is not equal to each other. It's because the gravitational force, that's something else. But the main part is the direction is different. If you take a reference point, if you take the sun here, if we are considering the sun as the 0, okay, so if we are seeing from this point, I'm going to stand on the sun, okay, the direction from here is going to be in this direction. So this direction is going to be in this direction. So these two directions are different to each other, but the magnitude is same. Let's consider the gravitational force in Earth and Saturn is going to be equal. Just let's assume that. Still, those two vectors are not equal. The reason? Their directions are different. Why? A vector is made by a magnitude as well as a direction. Understand? Okay? Right. So if a bus is going in this direction with 5 meters per second and a bus is going in the opposite direction with 5 meters per second, can we tell that the velocity of these two buses are equal? Can't. Can we tell that the speed of these buses are equal? Yes. Why? Speed is a scalar quantity. Understand? Speed is a scalar quantity, but vector is not. Understand? So if it is an equal vector, what are the two conditions that should be equal? The magnitude, that's obvious, as well as the direction. Okay, so like in equal fractions, that should be proportional, right? So but here you have to have the direction as well as the magnitude. So if you are going to take a vector, if you are going to solve a vector, okay, there's a rule in mathematics. If you have two variables, you should have two equations to solve that particular two variables. Okay, so if there's a one vector, how many quantities are there inside it? Direction as well as the magnitude. It has two variables. Okay, to solve this one equation, one variable, just a vector, we should have two equations now. Why? There are two quantities inside, the direction and the magnitude. Understand? So if we have two vectors, how many equations? 4 equations. So let it be the equation regarding a direction. Okay, let's tell the direction. If we add these two directions, it's going to be in different direction. That's also an equation, right? Because it can be a directional equation or a magnitudinal equation. Understand? So you should consider that if you are putting like 100 effort to learn about scalars, how much effort should you give? to learn about vectors, it should be multiplied by 2, because there's another part, a directional part, and that direction is geometrical. So you should have a geometrical knowledge when you're coming to vectors. Okay, so A level physics vectors is literally, it's that much simple. If you go to advanced level, vector is that much hard. Vector multiplications by vectors, really hard, really hard. Okay, let's go to that part little by little. So right now you'll know what an equal vector is. What's an equal vector? A vector, a quantity which has the same direction as well as the same magnitude is going to be a equal vector, right? So equal vectors, if there are two vectors which are equal to each other, they will have below properties. These two vectors can be called as like term vectors. So these vectors we can call as like term vectors. So they should be equal in magnitude, parallel in direction, and same in direction. So what's the meaning of parallel in direction as well as same in direction? That's it. So you can have two, I say that example here, a bus going in this direction and a bus going in this direction, opposite direction. This is 5 and this is 5. Okay, magnitude equal. Okay, this is parallel, but the direction is different. So these two are not. Okay, so when we are representing this vector three-dimensionally or two-dimensionally, we should consider 3 points. Okay, okay, we can't just tell we drew a vector like this and we drew a vector like this. Okay, these two are 5. Okay, so we don't have an origin, right? Someone can tell this is not that much specific. It can be rotated just when one is drawing it, he has tilted it. It can be. It can be those silly type of mistakes. So when you are equalizing a vector, you should consider 3 points. What are 3 points? Every time remember this. This is going to be a question from your first term. So every time it should be equal in magnitude, parallel direction, and same direction. So it's going to be parallel. It's going to be parallel as well as in the same direction, starting from one point and going to the next other point. Okay, right. So that's what an equal vector is. Okay, so for an example I have given you, this. If AB equals to CD and if AB is parallel to CD, this is a parallel mark. The direction of A to B is same as the direction is same as the direction, I'm not writing the part, direction of C to D, then only then AB is equal to CD. Okay, so just see why we mentioned the same direction part. Okay, you see. So let's think that the direction of these two are okay. The direction is what? These two are okay. Okay. So I know that AB is equal and AB is parallel. So I think that that's in the same direction. So I'm going to mention that AB is equal to CD. But what if I write it like this? AB is equal to DC. Same magnitude, they have said that, correct? Parallel, okay, it can be parallel. The same direction of A to B is the same as the direction of C to D. Okay, this is the next part that you have to learn when you are representing a vector symbolically. So you can flop these two letters. This is not just one term. This is not one term. This is a term that is made by two algebraic letters. So this can be swapped. You can write, if one is write like this, CD, CD, okay, is equal to, what I'm going to do is, I'm going to multiply this by, sub minus mark. So this is going to be in which direction? I'm going to multiply this in by negative. So this is going to be in this direction. So what I'm going to do is, I'm going to write CD, okay, this side arrow, this direction, and I'm going to multiply this by negative. Okay, understand what I did? I consider the negative of this, that is this. So if I multiply this by negative, it's going to be in this direction. So the negative of this CD is going to be equal to this. But we don't write it like this. We write it is equal to negative DC here. Understand? Okay, this is a little bit confusing, but gradually you will understand this. Okay, so primarily when you are starting, you are going to get messed up with this stuff, right? But gradually you will understand it. Okay, so here you have nothing to write because I have given them. If not, it will take time to explain this stuff, right? So now we are going to go to negative vectors. So I explained what a negative vector is. Okay, page number 7. Negative or opposite vectors, we can call them negative as well as opposite vectors. Okay, same. So the vector quantity is obtained by reversing another vector. We are going to reverse them. Quantity keeping its magnitude unchanged is called the negative vector quantity of the initial one. So it's going to be the opposite in direction but equal in magnitude. Is it parallel? Are they parallel or not parallel? They should be parallel, right? They should be parallel. If they are not parallel, unless it's in another direction, it can be another vector. Okay, if you take two vectors, in this direction 5 meters per second and another one in this direction, but it's not parallel, 5 meters per second. Are they equal? No, they are not equal. Are they opposite vectors? No, they are not opposite vectors. They are not opposite vectors. They are two different vectors. Okay, right. So after that, we have multiplication of vectors and those stuff. So basically in physics, pay attention only for this much. These are some summaries about this lesson. Okay, you have multiplication, division, and addition, subtraction of vectors. Okay, so I say that here in A-level syllabus or when you're studying physics, you are not considering division of vectors. Okay, and multiplication of vectors, they have two types. One is known as dot product. This dot product. Okay, and this is cross product. Okay, this is dot product and the next one is cross product. Here, when you're multiplying vectors, okay, right. So here, this is when you're multiplying vectors by a vector, vector by a vector. Okay, but you can multiply a vector by a scalar also. Okay, you can multiply mass multiplied by velocity, that's going to be momentum, right? Okay, so the next part is you can multiply a scalar by a vector. So that is normal. Why? Scalar has only magnitude, right? But a vector has a direction also. So when you are going to multiply something just by a magnitude, it's going to get multiplied just as simple. But the direction is the direction of the vector. Okay. When you are multiplying a scalar by a vector, When you're multiplying a scalar by a vector, let's consider mass and velocity. So velocity is a vector. So I have to mention this. Understand? Okay. So if this direction is from in this direction A to B, this is the velocity. This is the velocity. Velocity. If we take the momentum, so is multiplied by a mass. So this is going to be a much longer part. So this is going to be momentum. I can name it as CD. Okay. These two are parallel to each other. But this is multiplied by magnitude. The magnitude is going to change. If this m is greater than 1, so this length is going to be greater than this. If the length is less than 1, 0 point something, the length is going to be lesser than this. If this scalar has a negative value, this is going to be in the opposite direction. Understand? These are the small parts in vectors. Okay, right. So this is a summary of multiplication, but here when you're multiplying, so why I'm telling this much speedily is because you don't want this part. Okay, only this part is relevant, but that is easy. What you have to do, you just have to multiply with that digit, and you have to know this is in that direction. That's all, same as the previous direction. But if you come to this dot product, these two are going to be a little different, and you don't want those parts in your A-level syllabus, physics syllabus. But I'll just give you a small explanation. A dot product is if we multiply a vector by a B vector, we take the dot product like this. I have given you. So dot product, the equation for dot product is going to be the magnitude of A multiplied by the magnitude of B into cos theta. So theta means if A is in this direction, and B is in this direction, the angle between these two is going to be theta. So I will mention this part. This is a little bit huge. Shall I? Yes. Okay. This is dot product. So what a cross product is? A cross product is a little bit different. It is A into B. So you can represent a multiplication by a dot. Okay, you have to know that. Every time if there's a dot, that's a multiplication. Okay, so if you have xy, this is a multiplication. If you have x dot y, this is a multiplication. If you have x multiplied by y, this is also again a multiplication. So these four are same. So you have to remember that. Okay, right. So A into B. So the value, how we are going to find the value here is, we are going to find it like this. So this is going to be the magnitude of A multiplied by magnitude of B into sine theta. Look into this. If you all know these dot product and cross product, you can understand Einsteinian physics. Einsteinian physics is a little bit different. Just go and search. Real different. You deal with matrices, you deal with gradients and stuff. It's utter different. So when you're going to Einsteinian physics, this is for boy stuff. Okay, for your researchers. If you are going to learn about Einsteinian physics, you don't have a graph. Einstein, what he did is he flipped the axes. So what's the angle between x-axis and y-axis? It's every time 90 degrees, right? But to explain relativity, what Einstein did is, in those times, everyone believed that acceleration, the F equals gmm over r square. So that's the equation of Newton. Okay. So to prove Newton wrong, Einstein have to prove something new, relativity. Okay. For that, what he does is he changed the angle between the two axes of the graph. So normally you have 90 degrees. So from 90 degrees, you have that much big level of physics. Okay, so you all don't know about differentiation, integration, just a huge part in physics. But after Einstein came, he said that this 90 degrees can be changed. You can take whatever the value. So this is going to be multiplied by infinity. So the bulk of physics subject went to infinity. So until that, there was a huge lot that we have to learn on physics. After Einstein introduced relativity, this Newtonian physics was utter BS, and now it's different. So still you are learning about Newtonian physics. This is Newtonian physics. These are really puzzle. These are bitter truth. Okay, that means this is not the truth exactly. This is not what's happening. So if you are going to learn about Einstein, just search about him. He is looking everything from space. That's how he look into objects. Okay, not just like a moving car. He's going to think that the car is going to move in space. Okay, so if you're curious about Einstein, just search about vectors, dot product, and cross product. Okay, we multiply two vectors, but the way we multiply, we are going to have two results. Okay, we are going to have two results. So the class is right. Well, my goodness. Okay, so today you are done for the day. Next time you all don't have that much in vectors. It's really easy. You just have a lot of diagrams to draw. Understand? So we'll have a class after this. Who is going to another class after this? You. You. In what time does that class start? 1 o'clock. So here see, this is really unfair. You all came at 8:30. Okay, I missed 30 minutes. Okay, you all took a break of 45 minutes, almost 45 minutes. 45 in the sense it's almost 40 minutes, right? It's almost 40. So there also I missed how many minutes? 50 minutes, and here again you are going. So almost I missed 1 hour. So it's really hard to do like this. So you can do like this. Shh, wait, the guy. You can do like this. Wait a little bit. You can do this class from 8 to 12, or you can do this from 8:30 to 12:30. So you are going to so a lot of people are coming at 8:30 because it's hard to wake and it's really hard to come at early, right? So I can make this from 8:30 to 12:30. Then you are going to have only 30 minutes break after this class to that class. If you'll agree, I'll agree. If not, you have to be here at 8 a.m. Okay. Today there's a small issue because I forgot to bring my mic. So I brought it by a picnic. So I got a little bit late to set up these things. I'll make sure that this won't happen again. So the thing is, you should be at 8 a.m. or like in 2 weeks, I'll put a poll. You can vote it. So after that only I can change the time. Okay, right. So let's wind up the session. You can leave. Bye. Have a nice day.